Oasis Sales, and I support Mentor graphics tools, including pads and some of the HyperLynx offerings. Okay, so this is, I believe, our 5th installment of our Did You Know webinar series, just trying to inform customers, prospective customers, about what Mentor can really offer and how we can use some of their solutions to better your designs and alleviate some of the design issues that you might be encountering. So today we're going to be talking about HyperLynx DC Drop, and there's a couple of different packages that we'll be talking about with that, and I'll do a small demo for it as well. Okay, so if you're not very familiar with Oasis Sales or with Mentor Graphics in general, which is now a Siemens company, Mentor Graphics now provides solutions for really everything that you need in the EDA design space. That includes design of your actual schematic, the board layout, and then other electronics as well, such as integrated circuits and some mechanical tools as well. So they also have solutions for simulation as well as analysis. So that's what we're going to be talking about today in our HyperLynx PI DC Drop. So that's a very good solution for trying to alleviate some issues with power integrity on your your power distribution network. And then also through these both design, simulation, and analysis, Mentor provides cost-saving solutions. Just a small tidbit about Oasis Sales. We have been partnered with Mentor Graphics for over 16 years and have grown quite large through the territory of North America, and we're excited to be continuing that with the acquisition of Siemens. Siemens acquired Mentor Graphics just a couple months ago, so we're excited to see where that heads for us. So founded in 1986 was Oasis Sales, and we've been a premier partner with Mentor Graphics since, and we mostly focus on PCB design and the analysis tools. Just a little bit about our technical team. Myself, I am Kyle Lake. I'm based out of Portland, Oregon, and we also have Brent Klingforth, who is based out of Denver, Colorado. Just a quick tidbit on our sales team here. These are our prospective account managers for your territory. If you see that you're in these states and you're not familiar with any of these people that you should be working with to get more information on pricing, maybe evaluate a tool, or just have any questions, these are who you should be talking to in your territory. So we have Derek Pop, Lizzie Marsh, Andy Bowe, Pete Achilleos, Rick Truza, and Jason Johnson as well. We also have an inside sales team that is very good at quick turnaround for evaluations and general questions about our tools. If you're not sure exactly what you're looking for, these are great people to reach out to, Fawn Chang and Dennis Reynolds. If you'd like to just maybe take a quick screenshot of this, this is a good contact for general questions, and Fawn will be able to point you exactly to the correct person to talk to, whether it's a technical issue or pricing. And if you want to take a quick screenshot of that, Fawn Chang at oasissales.com. Just a little FYI for our next Save the Date webinar. I believe this is our last Save the Date webinar. It's going to be taking place on July 13th, so just about a month from now. And that is going to be about thermal compliance and our FlowTherm XT offering. Really excellent tool for full computational fluid dynamics and electronics cooling. So if that sounds interesting, please take a look at that one as well. Okay, so now hopping in to a little bit more of the technical side. If we're not familiar with our board system division within Mentor Graphics, these are really the 4 product families that we can provide, and we're very excited to help work with you on these. So Expedition is our flagship enterprise tool, very good for large, complex designs and companies that need an enterprise solution for component data management and other wraparounds like that. PADS, still a very capable layout tool. It's been around for quite a while. It's a very powerful solution for desktop-based projects. So if you don't really need an enterprise solution, and wraparounds for all of your component data management, maybe some PADs is a great offering for that. HyperLynx, again, it's a very well-known tool for analysis and verification, including signal integrity, power integrity, EMI checking, and we'll be talking about that a little bit more today. Valor, an industry standard for assembly, test, and manufacturing checking. So it's a very good job to make sure your board is going to be manufacturable and it can be assembled well as well. This is just a quick slide that shows the growing trend in PCB complexity. So as you can see in the graph on the right-hand side, we'll just see the red line increasing. That's the average leads per square inch. So as far as this goes back to 1994, the average leads per square inch is just exponentially increasing on boards. And that makes sense just due to the high density that a lot of boards are using right now, especially with high pin DGAs. On the left-hand side, you'll actually see a Technology Leadership Award, which Mentor hosts every year, and it just likes to show off very interesting, groundbreaking designs that are done with pads. So this particular board was done with pads on the left-hand side. Just kind of a roadmap of how pads has evolved in the last couple of years. So pads has really gotten a lot of breath given back into it, just to really try and make it a very good solution to really offer you everything that you need in electronic product creation. Okay, so currently we offer right in the middle, you'll see PAD Standard, Standard Plus, and Professional. And I'm not sure if all of you are on pads or you're not on a different tool or not using a tool right now, but this is what Mentor Graphics currently offers in the desktop solution space. Okay, and what we're talking about today, again, is HyperLynx PI DC Drop. And that is a solution that will work with every different CAD tool and as well with pads. So I'll show how we can kick that off from design in pads into the HyperLynx tool and analyze our power distribution network. This is just a quick slide showing what we can do with pads, schematic capture, obviously routing the actual board. Then we have constraint management, some FPGA optimization, DFMA for manufacturing, some collaboration with mechanical team, and then thermal analysis as well. Okay. These are our new offerings that we're actually have been talking about in this Did You Know webinar series. So today, again, we'll be talking about voltage drop with HyperLynx DC Drop. There's also an analog mixed signal solution for SPICE and analog mixed signal simulation directly within the schematic. We also have a DDR analysis with HyperLynx DDR. It allows you to compare your timings on your actual physical routed board to the JEDEC standards to make sure that your DDR memory buses are going to actually work first time. A new exciting tool is HyperLynx DRC. This is the graphical rule checker I was talking about for EMI. And then next month we'll be talking about Flowtherm XT, which is the electronics cooling. Okay, so now let's hop into the actual discussion about HyperLynx PI DC Drop. So if you're not familiar, really what is DC Drop? DC Drop is just a voltage loss that happens through a circuit, mostly due to impedance. And this can cause a large issue on your power distribution network on your different voltage planes within your board. Okay, so if the voltage drop is too large, some of your more sensitive components may not operate correctly if they're below a certain threshold voltage. So HyperLynx DC Drop does an excellent job of very easily and very quickly identifying where you might have these hot spots on your board, and you can go back into the pads layout, mess around with the plane a little bit, add some more copper, and then re-simulate to see if you're going to be able to meet your standards. So what really causes DC drop? Obviously the resistance of the plane, and then very importantly in these last couple of years with more BGAs, high pin count parts that you're using, is perforations in the power planes. So this can cause a Swiss cheesing, if you will, of the actual power plane and cause the power plane to be broken up by many vias going through that actual plane. So this can cause DC drop as well as a very high current density. Okay. So HyperLynx DC Drop allows us to identify those excessive voltage drops as well as high current densities. So why is high current density an issue? that can very quickly increase the temperature of the board. And with the increase of the temperature of the board or the plane itself, the resistance will increase, thus causing more DC drop. Okay. So current density is mostly caused by, again, neck downs and not enough copper for the current to flow through. So obviously that's going to cause some high current density through those areas of the plane. Okay, so DC drop just allows us to see if we have enough copper, if we have enough stitching vias, and then what's nice about the actual results, they come in a spreadsheet or an HTML report that are very quickly to actually send off to the design review team and just understand what issues you might be having. All right, and if anyone does have questions, feel free to type those into the chat box, and we'll definitely get to that. Okay. Just some benefits of HyperLynx PID DC Drop. It's very simple to use, very easy to use and set up. So I'll go through a demo, and you'll just see how quickly I can actually accurately simulate what our DC drop is going to look like on our power planes. Very powerful, very fast, easy to identify those issues. And what's very important to take note of is that it works with all major PCB layout tools. So it's CAD agnostic, we like to call that. Okay, so if you're using Altium, you're using OrCAD, you're using any other tool, most likely you're going to be able to import it into HyperLynx, run your DC drop calculations, and then understand what your power distribution network looks like. So that also is true for all of HyperLynx offerings in general. So if you are interested in HyperLynx signal integrity simulation, it will also bring in any other tool as well. Okay, so now I'm going to go ahead and actually hop into the demo. I don't see any questions yet, so that's fine. Again, if you do have any, type those in the chat box and we will hopefully get to those. Okay, so for this demo, I'm going to actually be showing it starting off in PADS layout and being brought into HyperLynx DC Drop. So I'll go ahead and open up a layout for us. And it's opening up the 3D right now. Just loading that. I will close that as soon as it's open. All right, so once the layout is open, so this is the layout that we're actually going to be analyzing. And just so we can understand, I'm going to take a look at our layer definition. So this is a 12-layer board, and I believe there are 4 different plane layers. Okay, so a lot of components on this board. As you can see, it's fairly dense. There's a couple of high-pin VGAs that might cause issue with all of the vias, the fan-out vias that we are using for those particular VGAs. Okay, so this is a good board to understand how we can look at the power distribution network and understand if there's going to be any issues. Okay. So the first thing that we do have to do before actually kicking it off into the DC drop tool is actually we have to pour the planes. Okay, so this is very important because if the planes aren't actually poured, we're not going to actually see any issues or see any planes in the tool. So just for everyone's information, if they are using PADS, I'm currently running it on version VX2.1, which is the most up-to-date version. Okay. So once we have the board ready to go, I just go Tools, Analysis, and kick it off into the DC Drop Analysis tool. So what this is doing is it's creating a file that can be read into the HyperLynx tool. And like I was saying, if you're using Altium, you can export a hype file, and HyperLynx can bring that in very easily. It's a native file to HyperLynx, and we can do that simulation all within here. Okay, so this is our HyperLynx board sim tool. If you have not seen this before, it's where we can do a lot of different simulations, including signal integrity, some crosstalk, actually do our DDR analysis all within here, and then also the DC drop. So in order to do that, all I have to go is simulate PI, simulate power integrity, and run the DC drop analysis. Okay, so it's going to open up the DC drop analysis window for us. And what we can see here is if I actually click on these different nets, these power nets, it's actually going to allow us to see what the planes look like in this little window. Okay, so just a very quick visualization to understand what the plane looks like and if that's the one that we actually want to analyze. So I'm going to use the 1.8 volt plane, and we can just take a look at that and see if we're going to have any issues. So the first thing that we want to do is actually maybe take a look at our constraints. So over here in the bottom left corner of the window, we'll actually see where we want to have our constraints. So our maximum voltage drop that we want on this particular power plane is 50 millivolts, maximum current 10 milliamps per square mil, and then a maximum via current. So we can actually, the tool will actually understand how much current is going through each via. Okay, so we can have those constraints in there and see if we're going to pass or fail depending on those constraints. So the next thing we want to do is actually assign models. So we do have to assign models, but we don't have to use IBIS models or anything like that. It's very quick and easy to set up. I'll expand this a little bit for us. So what this is showing is our different pins on this power plane. Okay, so you do have to know what pin is actually supplying the voltage and current on that plane. Okay, so for example, this is CR1 pin 2. So CR1 is the reference designator, pin 2 of that particular component. Okay, so the first thing we want to do on this voltage, our voltage supply, is assign a DC sync model. So what the DC sync model is actually going to supply current off of this. Okay. Actually, I'm sorry. We're going to assign a voltage regulator model on this particular pin because this is the voltage supply pin. So you'll see we can either have a simple or an advanced model for your RLC on that particular voltage supply net. Okay. So we're going to go ahead and actually set our DC sync for our different pins. So you'll see U2 has about 20 pins, we'll say, connected to this plane. So what I want to do first is I want to select all of these pins on U2 and assign a DC sync model. So what the DC sync model is actually allowing us to say how much current is being synced for those pins. Okay, so that's how much current all of these pins are pulling off of the plane. So very important to understand what that means. So we can apply about 21 milliamps to each sync, or I can apply this current to the entire group of pins, and then it will actually calculate it out and evenly distribute the current synced on all of those different pins. So I'll leave it on each sync, and we can understand that each one of these pins is going to take off 21 milliamps off of this particular power plane. And we'll see we have the voltage coming off of J8, 9, and 13. We'll see the model over here is a 1.8 volt with 1 milliohm and 30,000 nanohenries. So again, if I want to take a look at that, I can assign the voltage regulator model on there, and you'll see how it's assigned on that particular pin. Okay, so that's all we have to do. Very easy to set this up and understand what's going on this plane. So very easy and easy to understand as well. Okay, so reference net, we can assign a different reference net other than ground if we would like to, and understand how that comes into effect. But by default, it's going to use ground as a reference net. Okay, so once I have our models for the voltage regulator model set up, as well as the DC syncs, that's basically all we have to do. Okay, so we've got our voltage and current coming in off of these connectors, and then all of these other pins actually syncing current off of there. So now that we're ready to simulate, I'm going to click this checkbox to actually create a report. So this allows us to actually create an HTML report that will allow us to see all of the results on the simulation. So once we're ready to go, I'm going to go ahead and click on Simulate. As you can see, this is running in real time, very quick simulation. It's not really doing too much other than just simulating all of the current and the voltage on that plane for us. Okay, so the first thing that we actually see is that this HTML report pops up, and what this allows us to do is easily understand what happened on this simulation. So we'll see all by those constraints that we entered in, we get a pass for the maximum voltage drop. We only had a maximum voltage drop of 5.9 millivolts. So really that's doing a pretty good job of keeping a constant voltage all across that plane. But we'll see we fail the maximum current density that we set up. So we're getting about 27 milliamps per square mil, and I believe we set up a maximum current density of 10 milliamps. So that's flagging it for us right in there. And then the maximum via current, again, we passed that as well. If I click on the net now, we'll actually see all of the pins on that voltage plane and see the current going through all those pins as well as the voltage at all of those pins. Okay, so this is just a very easy to understand and nice little report all in HTML for us. We also have a reporter in a spreadsheet system here. What I can do is I can again take a look at the current coming on or off of those pins and then the voltage at all of those pins as well. So what I can do here is I can just select a U14, which it looks like it's taking about 21 milliamps, and the voltage is 1.79 volts. If I click on there, it's actually going to highlight it in the design, show us where exactly that pin is on this power plane, and allow us to understand and troubleshoot if that's not going to meet our requirements. Okay. So the last thing I want to talk about is what's showing in this 3D window. So this is a 3D representation of the voltage on our plane that we're working with. Okay. So the higher the actual plane is in this 3D representation, the higher the voltage. So if I hold the control key, for example, and actually place it on the pin, on the plane, we will see what the voltage is at that particular point. So we can actually hold the control key and see where the voltage is lowering too much under our standards. Okay. So very powerful and easy to understand what's going on here. We also have the ability to set a threshold. So if I make this a little bit easier to see, we can actually see a threshold. So I can set a threshold for 1795, for example, millivolts. Now we'll actually be able to see this plane area, or a cut plane, showing everything below this gray area is going to be failing on that threshold. So we could just show those thresholds to understand where we're below that voltage on that plane. Okay. So like we saw in the report, the voltage drop really isn't too large of an issue on this board, but we do have to worry about the actual current density going through this plane. So what I can do is I actually go into the visual options, and we'll see the graph type. We currently have it on DC Drop. Now if I go to the current density, you'll see the gradient from blue to red showing our current density. So if we zoom in here, you'll actually see a high current density, and that's because there's not very much copper between these two pins. Okay. So again, we had our maximum current density that we wanted for this particular plane to be 10 milliamps per square mil. And you'll see that the gradient is going up to about 27. And again, if I hold the control key, we'll actually see what the current density is there. I can also change the scale a little bit if we want to highlight a little bit higher current density or lower current density, easy to understand where we're seeing more current on this plane. Okay, so what we can do in a use case like this is if we're seeing a lot of issues with current density or the actual DC drop on this board, we can go back into pad layout, possibly add some more copper right where my cursor is here, if we have room for that. and then kick it back over into the HyperLynx DC Drop, simulate that very quickly, and see if that issue has been alleviated. Okay. All right, so that is all there is for the DC Drop simulation. Very quick and easy to set up, and it gives us results that are very accurate as well. Okay, so we've got the report, we've got our results, and we can either go back into layout, fix the issue, or if we feel comfortable with our results, we can actually move forward with our design. Okay, so I still don't see any questions in the chat box. That's all right. If there are, we can talk about those at the end of the session, or if you'd like, you can email me with further questions after we're done. Okay, so just a quick recap on why HyperLynx DC Drop can provide a lot of benefit to you and your organization. Quickly assesses voltage drop, validates the PDN or power distribution network, and find problems before boards are released. I think this is probably the most important aspect to HyperLynx DC Drop. Power integrity issues, a lot of people don't think about them until they've actually happened to their particular company. It can cause very difficult to ascertain why it's happening, but it can just cause boards to fail. So if you don't understand your power distribution network, it can really come back to bite you. So we are available to have a free 14-day evaluation. If you like what you saw here and think that it could be useful in some of your designs, please reach out to us, and we'll be more than happy to give you the evaluation and also help support you if you have any issues or have any questions on how to use the actual tool. We are actually offering a coupon as well, so if you'd like to purchase it, if this seems very interesting, if you've demoed it before or actually eval'd it as well, we are offering a 25% off coupon right now, so just let us know, and we'll be able to help you out with that. Okay, so the last thing I'm going to talk about is just, again, save the date for the next Did You Know webinar series called PADS, or for Thermal Compliance, featuring our PADS FlowTherm XT tool. Okay, and that's going to be happening on July 13th. All right, so that's all I had prepared. Again, I'll throw my contact information up here just so if anyone wants to have any questions, please reach out to me, and we can help you out with pricing, we can help you out with an evaluation, or just any other technical questions that you might have. All right, that's the end of the webinar. I don't see any questions, so thanks again for attending. Have a good rest of your day.